Okay, we've already covered hypothesis testing, but this is a more modern approach where we use something called p-tests. Okay, and in p-tests we change our point of view. Uh, Previously we've talked about two-tailed tests, which has its test statistic, and we have a right-tailed test and a left-tailed test which share the same test statistic. And in these tests, we set a limit on how far wrong our test statistic can go, whether it be too big, or in the case of the left-tailed test, if it's too small. We set some limit on the test statistic. Now, there's another way of doing this which calculates the probability that a test statistic is as far wrong as it is. And then we set up our test criteria so that instead of rejecting if our test statistic fits in a particular way with respect to a critical number, we'll reject if the probability p we calculate is too small. That is, if it's less than the significance. And so to do this, all we have to do is to know how to calculate the p-value for each of the types of tests. Okay, see, so with a two-tailed test, our test statistic is an absolute value of our z-score. Okay, and so that absolute value is hiding the fact that if we ever have a negative on it, it erases the negative, so we're in danger of losing some stuff. Okay, so we will have to compensate for it. So right now, let's say we calculate we take our x bar and we take our test statistic, and it gets to this point right here. We can calculate to calculate this out in this direction is pretty easy. What we do is that the area from here, okay, from the point of the test statistic back to infinity is stats.norm.cdf of the test statistic. That gives us the probability of everything, cumulative probability up to here. The little tail, okay, so from this point on will be 1 minus that probability, right? Because it's just like you forget what happened to that point and what would it take to build up to 1. Okay, now to get the other side, the case, well, hey, what if this were negative? You take 2 times this, and so p is 2 times quantity 1 minus stats.norm.cdf of the test statistic. Now, for the right-tailed test, we're just interested in, the point beyond the test statistic. So, what is this area here? Is it too small? Is it less than our significance? So you calculate, so this part is the area under the curve from negative infinity up to here, okay? And then p is just 1 minus that, okay? So this is our p, and so we reject if p is less than the significance. And the left-tailed is the easiest of all, okay, because say if our test statistics right there, we're just interested in the area up to that point, which is exactly this right here. Okay.